Good evening, everybody. My name is Travis Swiderski. I'm joined with Andy Weinberg here tonight. We appreciate all you guys stopping by. We are also joined with, you'll hear James on the line. So for anybody who is on YouTube, he's going to be your connection. If you guys have any questions throughout the night, please direct them through James in the chat function. He'll have them live to us. We're also live on the SEMA floor as well. So Josh is your go-to guy there. If you guys have questions, like I said, feel free to ask those of Josh on the show floor, and he can direct those to us live as well. So tonight we're going to talk a little bit about where we started with MIG welding MILLERMATIC style machines, and how that kind of transformed into what is the current day multi-process, MULTIMATIC style machines, and kind of what makes them unique, what makes them different, and what makes the lineage today a whole lot better than what it was in the past for an all-in-one style machine. So like I said, feel free to ask questions along the way. We are going to do some questions at the end and have a chance to give away, or have a chance to win some free stuff, I should say. So, Andy, you want to tell us a little bit about yourself and who you are and what you're doing here and why you're our aftermarket performance guy?
Yeah, well, basically, I grew up racing cars my whole life, but I grew up in a welding family. My dad owned a welding business, and I unfortunately didn't want to take over the family business, joined the Army, get some money for college, uh, went to school for electromechanical engineering, and darned if I didn't get a job at a welding company. So here I am. I have morphed my passions, and I've built cars pretty much my whole life, race cars, street cars, performance vehicles. And I do speak race. I take care of all of the motorsports teams for Miller, and that has morphed into the aftermarket and performance industry as well, since they are very close cousins. So yeah, so if we have any questions on your car builds as it relates to welding, I can definitely help you out there.
Yeah. Like I say, if you have those questions, I see we've got a couple people already online commenting. Feel free to shout those out along the way. We'll get to them either where they make sense in the presentation, or as they come up, if it makes sense there. Anything that's more complicated, we might ask you to send us an email to the shoptalklive@millerwelds.com so we can answer those questions for you as well. But like I said, if you stick around to the end, we're going to be asking some questions of you guys as well, and James will be your direct line back to us. So we appreciate everybody. We're going to start out kind of where Miller started with the all-in-one style, what you would notice as the MILLERMATIC type of machine today. That original machine that came off the line was the MILLERMATIC 35. You can see it here, and Andy's going to tell us a little bit about what that machine is, why it's the 35, and kind of how that changed MIG welding.
Yeah, so in MIG welding, which is a process that has been around for a long time, was really relegated to the industries that produced a lot of high-end products. So it was more of an industrial machine. This was a real step up to make a machine that had all in one, where it had the machine, welding machine, and the wire feeder built into one cabinet. All the other machines on the market were big power sources that had an external wire feeder sitting on top of it or in a remote fashion. So this made it a lot more feasible to a smaller job shop, even a home hobbyist, to have one in his or her garage. So the MILLERMATIC 35 was called the 35 because at the time, 035 wire was one of the most common wires available. So the machine was designed around that wire. So if we actually take a look inside the machine and how it was designed, you'll see that there's a lot of wires, copper wires, aluminum wires, transformers, stabilizer coils, and that's basically what this machine was designed as, is a transformer, stabilizer, rectifier. So it transforms your line power to welding power, and then it's that step that voltage down. Then we rectified it and turned it into DC. And then there's a stabilizer coil that smoothed it out. Now that stabilizer coil and the transformer magnetics, which determined the arc characteristic, how it actually melted the wire into the base metal, that's all designed into the transformer and stabilizer coil. So when you talk about transformers, that really determines what kind of machine it is too, because if you wind your transformers really tight and have very strong magnetic coupling, it's a constant voltage transformer. Where MIG welding, when you set the front of the machine, you're actually setting voltage and wire feed speed. Now, if you're working with a stick machine or a TIG machine, you're adjusting current on the front of the machine. So it's actually a different design transformer. So that's why back in the day, you had separate machines for different processes. You had MIG machines and you had TIG machines and stick machines, and they all had different design transformers.
Yeah,
So
because if you look at
that
these
was
transformers, the biggest thing there is, like Andy had said, you're two very different processes. If you take and you think about the cross section of an 035 wire and the kind of power that it takes to start that wire off with a nice crisp clean weld versus what does it take to light off an 1/8 inch 7018 electrode. You're very different in what those processes are looking for. The downfall to that transformer style machine was to try to make one of those machines do everything well. You're limited on how much you can do because, like Andy said, your differences are mechanical, physical changes in the different sizes and the electrical components that you put in, in the pieces of copper and steel and aluminum that were in those machines. From an electrical perspective, they were pretty basic. You got power coming out of the wall, you got power coming out of the end. And we didn't have a whole lot of options back then of what we could do to control that, and take two very different machines and mix them together. But as we started moving forward, especially schools, shops that, were maybe a smaller job shop that didn't have a lot of square footage, they didn't have a huge building, things like that, there was a need for that 3-in-1 style machine. But the challenge was, at the end of the day, you'd get a 3-in-1 machine. You can see that machine there on the right. It's got most of the parts there. It doesn't even have a feeder included in that photo at that point. So you get one power source and a lot of other things you have to add on to try to make all those processes work. And at the end of the day, you still have a machine. Yes, it will do everything, but it doesn't do everything great. It does everything okay, but it doesn't do anything, exceptionally well on either end because you're playing that give and take to, make a machine that will start a stick electrode, but at the same time isn't going to blow the wire apart completely when you go to try to go back to sheet metal. So maybe 1/2 inch steel would be great, but you try to get down to sheet metal, you're a whole different ballgame trying not to blow through. So those early vintage machines like the SHOPMASTER that were truly, those transformer style machines, we had a lot of problem, trying to do everything great. So, and like I say, if you look at this from a size perspective, there's a lot of pieces to this and a lot of complexity just to get it hooked up. And like I said, this one at the end of the day doesn't even have a feeder with it. So you got another one you have to throw on top of that as well.
Yeah, and it was just
difficult from the word get go, and the cabling that was all in the way, plus changing it from one process to another process involved a lot of switches and things like that you had to change too. So it wasn't easy or comfortable. So, when you fast forward now to the current machines that we make today in the multi-process family, now those multi-process machines are all inverter, all electronic machines. So, in one way, it's almost like we're creating the arc performance artificially because we can adjust all those components individually in the circuit board and the microprocessor. So before, when we were relied on the magnetics of the transformer to give us our arc performance, now that can all be adjusted electronically. So it made multi-process machines much more attractive and feasible and also financially easier to purchase. So now that we've come into this type of reality, we have a machine that welds every process great because we can individually control each one of those. It also makes changing things from one process to another easier too. Now we talk about one button that we can push and change processes without having to change cables, without having to change 3, 4, 5, or 6 switches and a big lever. So it's much more user or operator friendly.
Yeah, because like say some of these older ones, even if they did have an internal polarity switch to change, from one process to another, it was still going to be a pretty large knife switch in order to do that. And if we look back at the last photo here, the size comparison of these side by side is kind of off as well. If you look at that older style SHOPMASTER machine, that thing's going to be half the size of a refrigerator. Where if you take that 220 off from the cart, it's more like a suitcase that you're going to be taking to the airport size on your carry-on. So you've shrunk
Yeah.
quite a bit there, and you can see on the internal photo of the inverter, obviously you're going to see a lot of PC board stuff there. There is a smaller version of the transformer and the stabilizer and stuff behind this, but you're looking at parts that would fit in your hand versus the bed of your
Yeah.
pickup truck. So you're
Yeah.
gaining a lot
And the
of
efficiency,
weight
yeah,
to.
the efficiency ratings go way up. So now you're talking about a machine that draws probably a third, at least a half less than what the other machine did too.
Yeah, and that's especially true if you're looking at one of these multi-process machines to go down the road of AC TIG. Those old ones, if you look at, not necessarily the SHOPMASTER, but that did have that capability too. But if you compare the older style TIG machines where you start getting them out of phase, those things are drawing huge amounts of power out of the wall. Where these newer style machines, whether they're dedicated TIG machine or MIG machine, the multi-process, it doesn't matter. These inverter style machines are going to be much more electrically efficient than what we're going to see out of that older equipment. So part of that comes down to what people had in their garages as well. Most people, like that SHOPMASTER or an older style TIG machine, you might have to have a 100 amp service, 120 amp, 125 amp breaker to get that thing to run at 100% capacity, where for most houses back then, that was the whole service for the whole house. Where these newer style machines are made to run on a 30, maybe a 50 amp breaker on some of the larger ones. So not only does the size get smaller, they're more electrically efficient. They draw less power, but it's a whole lot easier to get that circuitry into your home shop, smaller shop, than it would be the older machines that were really based around industrial kind of environments as well.
Yeah, and keep in mind too, Trav, that these machines now also, a lot of them are 120 volt capable. So that's something unheard of, before too. So, even on 120 volt, this machine still has the capacity in on AC TIG easily to do eighth inch material or even a little bit thicker. So, that's something that you wouldn't have heard of in years past either. So, this again opens up the capability for the home user to use it and be a lot more flexible.
And a lot of these machines are doing it, just by changing the plug on the back of the machine. You don't have to physically go inside of them and change them from 240 to 120 or whatever it might be, and then risk, hurting the machine if you've got it on the wrong one and you plug it into the wrong power on the other end. That process is a whole lot easier. So the whole kind of transition from the MILLERMATIC only style machine through the 3-in-1 or multi-process setup really is coming back to that home market, the small shop, the fab shop, where again in the past those machines might have been available, but they were really aimed more at higher education style industrial shops or true fabrication shops that have different power, a lot more square footage, typically forklifts to move stuff around, that kind of thing. Where now the home hobbyist is getting a lot more into their welding equipment, and they want to have one machine that they can put in a smaller footprint off to the side in their garage when they don't need it. It's not taking up 2/3 of their shop space that they have in the corner for their equipment. There's a lot of advantages going to an inverter, but that inverter is truly what has allowed us to get to these 3-in-1 multi-process machines that do everything, like Andy said, really well. But you're not giving up a lot of things to get there either. We're getting to the point now where most of the asks are there on these newer style machines. So part of that comes down to setup as well. I know Andy wants to talk a little bit about setting these machines up, and then we have the opportunity to, Andy's there live in his shop. We can go through some live setup of these machines so you can truly see what it looks like to go through the buttons versus just on the computer screen here. And then Andy might do us a few demos as well. If we've got questions out there, like I said, make sure you route those through James. Questions for Andy in his shop, things like that. Anything you want to see on the table, maybe we can pull that off as well. So if we look at the faceplates here, Andy, you want to go through kind of what we're looking at here and what's so much better?
On the left, you obviously see the MILLERMATIC, the very first MILLERMATIC, and you see a gaggle of wires there that actually are part of the voltage adjustment. You actually had to unplug the the bottom cable on the yellow jack plugs and slide it over to increase or decrease your voltage. And then you had a knob on the upper right hand corner that adjusts your wire feed speed. So it's not hard, but it's also not easy. And then when you take that kind of technology and then add a multi-process unit to it, now it even becomes more of a problem because now you got to switch polarities if you're going to be working with stick or TIG, and it's just a handful. So if you look at the right hand side here, now we have a process control switch, which actually I can kind of do the same thing on mine. So if we look at the one I have here, I've got my process control is all done with one button now. I can slide this up and down. The machine will give me a basic configuration to set it up as far as how the cables should be run, and it'll give me a main screen. Now, the setup on the older machines, you had to know exactly what voltage and what wire feed speed you wanted to run for whatever material thickness. Now, back in the day, your average thickness could be calculated as a rule of thumb, like 1 amp per 1,000th of material thickness. Well, what if you don't know any of that? So now we actually have what's called auto set. So in the auto set mode, all I have to do is tell the machine what wire size I'm putting in and what thickness of material. As I tab up or down on my thickness of the material, you'll see that the target voltage and wire feed speed change. Now, the cool thing about this technology on this machine is it still puts you in a weldable range that doesn't allow you outside of that, but still gives you the flexibility to fine tune it within that range. So I can slide up or down and it's going to give me a minimum maximum that's going to be kind of in that range, which is kind of cool because depending upon joint configuration, if you're welding a fillet weld, that's going to take a little bit more power than, say, an outside corner weld or just a butt joint. So that gives you the flexibility to stay inside there. Now, for me, I tend to weld a little slower than some people. I tend to put my puddle profile in there. So sometimes, even if I'm welding, let's say, 1/8 inch material, I may even drop it down to the 14 gauge setting, but then just turn it up a little bit so I can kind of get closer to that overlap, right? So this makes things so much easier. Another cool thing about this machine in particular is a technology that we incorporated called QuickTech. So what QuickTech does is I can pull the trigger on my MIG gun and it will run that process, or I can literally just step on the foot control and the machine automatically switches over to the TIG process. So it was that quick, right? You're not waiting for it to switch over. I don't have to go back to the machine and push my buttons again to get it to go back that far. Then if I want, I can come back here and pull my trigger again, and you'll notice the machine automatically switches back over. So really there's no waiting. I don't have to wait 30 seconds. I can just step on the foot pedal and go. Now, I use that a lot when I'm working in my car. Sometimes I'll be tacking something in place. It might be part of the roll cage. I'll tack it with some MIG, and then I'll go back and immediately start TIG welding it. So I don't even have to climb out of the car, come back to the machine, reset it, change it around, and it just makes things a lot more user-friendly.
Andy, we got a question for you coming in. I know you had one of these machines down in your shop when we had one out in Vegas a couple years ago. JJ asked if we could talk a little bit about the Miller Fusion 160.
Oh, the Fusion 160? Yeah, so the Fusion 160, actually, yeah, I've worked with that quite a bit. The Fusion 160 has it's an engine drive actually, so it's really a stick machine, but it does have auxiliary power so that you can actually run external machines like, say, a MILLERMATIC 211 like I have on top here. One cool thing about the Fusion that I actually love is when you go to the side of the machine, there's a little access panel there. If you open that up, there is a plug that actually plugs the stick machine part of the machine into the generator part. It's behind an access panel. And that plug is the standard 240-volt plug like you would find in your garage or something. So you could actually plug one of these machines into the Fusion 180's power plant using that standard plug. So you don't even need to get any goofy adapters to plug it into the front of the machine. Now, the only kicker to that is on the Fusion, because it does have an auto idle type circuit, you want to turn it into the high idle or high run speed when you're plugging in external equipment, external welding machines to the Fusion.
And that's typically, when you get any kind of engine drive where you're running auxiliary power kind of on the top end of what it's capable of, turning it to that run instead of a run idle switch is a good idea anyway. But that machine kind of quasi takes the multi-process a little bit further in the fact that, you can use that power shift to use the engine. You can use shore power. You can use that to plug, like Andy said, your equipment into the auxiliary power, the engine drive itself. So that one gives you a lot of flexibility built into a pretty small compact case. So that's another one that we see people throwing on service trucks or, as auxiliary power that people might take with them in their pickup or something like that, and, be portable and give you a lot more option than if it was just a stick machine alone. So
Yeah, we call it portable, but it's still a two-person lift for sure. I mean, if you're throwing it in the back of your truck, it's definitely
you're not two-person lifting the Bobcat.
No.
I mean, at least I'm not. Maybe some of you guys out there are. Not me. So hopefully that covered your questions on the Fusion. If not, give us a couple more. But like I say, anything that you guys have along the way, feel free to ask James on the YouTube side of things, or if Josh has anybody there at SEMA that's got any questions, we're more than willing to answer those for you as well. So Andy, I know you talked a little bit about process switching is one thing that's extremely convenient on these newer style machines. So again, if we look at multi-process from the perspective of more the home hobby, the light manufacturing type of facilities where you don't have a lot of square footage in your shop, you don't want 3 machines lined up. I want one machine that I can kind of do everything. Can you give us a little bit of look on something that is kind of the most common? I know you had said you use your TIG setup for tacking potentially and then running out, on what that would truly look like on a demo.
Yeah, I can do that on a demo, or I can even show you where I did it on one of my cars too. If I can, let me demo it first. So I'll show you what it looks
Both.
like. Yeah. All right.
So as Andy gets set up and going, we are going to give you the warning that you want to make sure before you start welding, you want to read your instructions, follow your manuals on the equipment before you get going. Wear all your safety gear like Andy's putting on here for us.
Yeah, and I do have a camera here, so I'll switch over to a weld cam.
That resolution looks beautiful here on the show floor, Andy. Nice work.
Awesome.
Let's see if his weld looks that way.
It's been a year and a half, so maybe it's a little rough.
Well, that, and I had surgery on my neck, and I still don't have feeling on my right hand. So it'll be good.
We don't want excuses, Andy.
I'll get there. I'll get there. Okay, so I'm setting my machine for the 1/8" setting. So this is going to be one of those, I'm going to kind of demonstrate that tacking and then immediately switching over to TIG.
So Andy, I know we have one of the people in the chat starting out is working on a frame, 15 years old. So congratulations for getting into a excellent trade early in what you're doing and building. So it says they're working on the frame of a car project in their garage. So is this something similar to what you would see there on?
Yeah, well, on a frame, depending upon what I'm doing, like if it's a stock frame and I'm kind of channeling it and you're boxing it in, I would definitely use depending upon what the customer's wanting too, right? I would definitely use the MIG to tack things in place, and then probably TIGging the rest of it. So it just depends on if they want it MIG welded all the way or TIG welded. Tacking it obviously tacking some things with TIG sometimes is hard because you're holding it with one hand. It's hard to do that and maybe use your filler metal. I like to channel things so that I actually, when you're meeting that joint, that it's not overlapping. I like to actually have it so that it's just on the edge, so you fill in that corner with the weld, if that makes sense. So for me, sometimes it's difficult to clamp it properly and have it all held in place. I like to just take and hit it with the MIG gun first. And that's what I'm going to do here, and I'll show you kind of how I do it.
So he's getting running there, James. If you got any more specific questions about the frame that you're working on, feel free to throw them out there and we can answer any questions you might have on that project.
Okay, so here this would be kind of my imitation of just doing a spot tack in a couple of places.
It's beautiful. You kept them all right in the camera range, so nice job.
Yeah, it's trying to do, which is going to be tough now on the TIG part of it because I'm going to be kind of in front of you. So
just do it wireless. You'll be fine.
Yeah. Now I haven't stepped on the foot pedal yet, but as soon as I step on the foot pedal, the machine is going to automatically switch over, and you'll notice that it'll start immediately.
And when this switches, it's going to switch to the last parameters you welded at, correct?
Right, that is correct. It remembers exactly what you were welding with, so you don't have to go back to the machine and readjust your settings at all.
Yeah. So if we look at that versus the SHOPMASTER of years past, where to do what Andy just did there, from going from that MIG tack to the TIG weld out, you're going to have to go back, make sure your feeder's set up, switch your polarity, change all your leads, make sure you're hooked up correctly, make sure your gas is switched over, and then you can get up and running. So it takes a few minute process at best and takes it down to a few seconds.
Yeah.
So huge advancement there in the multi-process machines of years past into the multi-process machines that we see today.
Yeah, and another example of that would be, I can probably, let me bring you mobile. So when I was putting the fuel cell frame and can in the car, some sections of it I MIG welded. So right around here where I did this body tie-in, I MIG welded that. I MIG welded the bottoms here, but then everything else was TIG welded. Anything on the inside of the can where the fuel cells sit was TIG welded. This was all TIG welded. So all that was done at the same time. I didn't have to actually leave my car to go back to the welding machine and reset everything just because I wanted to MIG weld it versus TIG weld it.
Right. And I know I've kind of talked a little bit about how a lot of the market for these newer style 3-in-1 machines is the home hobby, the small fab shops. But I know I came down there a couple of years ago with you, and we pulled a lot of those dedicated MIG machines and dedicated TIG machines out of some of the NASCAR or high performance type shops down there in NASCAR, and pulled those out and put in the 255 and 220 style multi-process machines. So, even though that's where a lot of the market's headed, that's not to say that these pieces of equipment don't survive in those types of environment as well.
Yeah. You could probably switch me back over.
No plans on your whiteboard.
Yeah, that's actually.
You must not have any projects going on.
Well, that's actually covering a window. The whiteboard is behind me on the wall. So yeah, I love that machine for that kind of switchover. I also have a Multimatic 235 with me here too. Now this machine is a little bit bigger in capacity and duty cycle. So it makes it kind of ideal for more of a job shop type situation. It has bigger drive rolls, a bigger drive motor. It's Multimatic in the fact that it does stick weld, TIG weld, DC, and MIG weld. So it's a little bit different than the Multimatic 220 that we just looked at, but it's still in a price point that was pretty close to where the older MillerMatic 212 was, if you're familiar with that machine. It was around for a long time and kind of a staple in our MIG platform. So this is a nice upgrade to, say, a MillerMatic 212. It has digital meters. It has that great AutoSet Elite that we just talked about, and it has DC capability for doing TIG steels. So all your steel, stainless steel, that kind of stuff.
Most everything other than aluminum or mag. One of the questions we had come in, Andy Saul asked us, what was the number of the TIG rod that you used in your demo? So your filling material.
It was ER80SD2. It's a filler metal that I like to use for chromoly and some of the higher strength steels. The type of roll bar tubing, cage tubing that I used on my car is called Docol. So it's a high strength steel. It has similar strength profiles as chromoly, but better life fatigue cycles. And it's more flexible on the welding side because the Docol can actually be MIG welded. So we don't recommend MIG welding chromoly. It's kind of too harsh for the heat effect zone, and you could develop cracking at that point. But we know people do it, but we typically don't recommend that. Whereas the Docol, you can. So I like the Docol because the Docol, I'm attaching it to the frame and the frame connectors inside the car. I'll actually MIG weld those areas and then TIG weld the rest of it.
Excellent. Another question we got come through: are we working on any new helmets? I would say they are always working on new things in the PPE realm of Miller.
Yep.
And then the next one, on the Fusion, there's a knob for arc control. Do you use it with DCEP or DCEN?
On arc control, that is going to be for your EP or stick. So when you're stick welding, arc control will give you what welders like to call dig. So it gives you a little bit more arc force when you're laying your stick electrode into whatever joint you're working with. So if you pushed it too hard enough, you'd actually stick it, right? So that's stick welding. But you could turn that arc control up to the point where it gives you a little bit of boost amperage when you get to the point where you're laying the stick electrode in the joint, that it actually bumps your welding amperage up a little bit to keep the arc established.
Excellent. So enjoy the questions. Keep them coming in. Like I said, if you guys stick around here till the end, just a couple more minutes, we're going to go through and ask you guys some questions of what we've covered here today. You guys have a chance to win some free stuff from us. So the way that will work for YouTube, you guys will answer in the chat function. Whoever James sees come through as the first correct response will be the winner of those. Know that might not come through the same on your end as it is on ours. We've seen quite a few different times where the feed that comes back to Miller is ahead or behind of what you see on your personal. So if you have any questions, you don't think something's quite right, feel free. The Shop Talk Live email will be up at the end. You can reach out to us there. For anybody who wins some of that gear, make sure you email us your contact information to that email as well. Like I said, it will be up. James will throw it in the chat here in just a little bit before we get started on that. But make sure you guys are ready, like I said, in the chat function if you're looking to answer some of our pop quiz questions for you. So, Andy, anything other on your project, on your car, in your shop that I know that 220 is one of your main go-to machines. Anything else that you specifically use that multi-process, piece for, or anything maybe that you used a MIG specific machine for. We covered on the MIG side. We didn't talk about some of the more advanced end of the MIG side. It's something that we still run some pulse capability. The multi-process machines do it as well. So most of the stuff that we see in a normal MIG machine, we can talk about in a multi-process machine, but there are definitely the MIG only versions of those machines still available. The cost is typically going to be a big driver there, or a lot of times if you're working on bigger fab, TIG's not necessarily the right process for you. So a lot of times those MIG machines are still the ticket. But anything that you've got that you use those on?
Yeah, definitely. You mentioned pulse. I did a pulse project. I used a MILLERMATIC 255 that I borrowed. Now that has pulse capabilities, and that's one neat thing about the inverter power sources, because they have such a high response rate to the arc that we can control it thousands of times a second now. So we can control how fast the current rises and falls, and we can pulse that on and off really quick. And that adds a different capability to the welding arc, where if you're familiar with some of the arc transfers, we talk about short circuit transfer, which is just regular MIG. And then we talk about spray transfer, which is the voltage being turned up higher, and you're really actually spraying the weld material into your weld piece. Well, pulse MIG is kind of a combination of the two. It allows you to get some higher arc transfers, but gives you the flexibility and out of position capability that short circuit MIG does. When you're spray welding, really that only works in the 1G or the flat position, because the arc is fluid all the time. So if you were out of position and you're trying to weld, say, vertical up or down, that really doesn't work too good with spray.
Yeah, she's a little too hot, wants to fall right out.
It's right. Yeah, it doesn't.
It'll end up on your forearm.
Yeah, it doesn't give the arc chance to solidify. So I did a job with that. One of my real projects on Real Garage coming up here. Actually, it was last week. They released it on YouTube. I made a 3/8 thick swing out equipment stand to hold my slip rolls. I used to store my slip rolls up in the loft, and it was always a pain to bring them down and clamp them to a table. And so I just made something out of that thicker material, and I used pulse for that. I did that just because the material thickness was so thick. And again, the MILLERMATIC or MULTIMATIC 220 that I have, that would have been on the ragged edge for that. So I used pulse for that, and I liked it. The other thing I like about the newer machines too, is again, I can switch from aluminum to steel. I have a spool gun hooked up to it, so I can do pulse MIG on aluminum. And I could also do pulse steel. Now with the programming capabilities we talked about earlier with the microprocessors, there is actually a gas that we can use for short circuit MIG and pulse MIG. It's 9010 gas. The regular short circuit MIG gas is 7525. That's argon and CO2. Well, that doesn't have enough argon to run a pulse MIG arc and still make the arc stable. So you need that 9010. And fortunately for us, the engineers at Miller thought, well, hey, why not make a program that runs them both, so we don't have to change gases? So that's a neat feature of the MILLERMATIC 255.
Yeah, and that's something to keep in mind. So as we look at truly MIG multi-process, what's right for you? If you look at a lot of these machines, the 255s, for example, if you see the MILLERMATIC versus the MULTIMATIC on the TIG side, the MILLERMATIC is going to be essentially the same machine, but if you don't need that extra capability, you don't have to spend the money on it. You have the option as a MIG-only machine. So you've got a lot of options on what is right for you. You can kind of pick out, tailor the machine for what you need. We've got a couple more questions we're going to cover here, and then we're going to get into the giveaway side of things so we can get you guys on your way tonight.
Andy and Travis, we have a question from the show floor as well.
Sure.
It had to do with ways to make some body work easier, maybe alternative metals or anything that you would recommend to try and help take heat out when you're doing some body work.
Yeah, excellent. So when I do body work, there's a couple things. First of all, is when working with heat, I'm still a fan of the old school way of kind of force cooling. I'll spot tack something and then I'll force cool it and I'll force cool it with some air. But one of the things you can do too is explore using silicon bronze. Now, silicon bronze is used quite heavily in the automotive industry. It's not new. But what a lot of people don't do is they don't use silicon bronze with TIG. And I think that is an overlooked area that you can use silicon bronze with TIG to help keep the heat out. And we'll use that quite a bit. One reason silicon bronze is so great with bodywork is unlike regular TIG welding, you don't have to get the base metal fluid before adding the filler metal. Silicon bronze, you actually don't want that. So silicon bronze, you just have to heat the base metal up high enough so that it actually melts the silicon bronze. It's more like it's more like soldering or brazing, right? Exactly. It's more like that than actually welding, but it's very cool, and I like it also because silicon bronze works with dissimilar steels or dissimilar materials. So and another thing I like silicon bronze is it metal finishes real easy because it's soft.
And that's what we see it coming back a lot in body shops too. Part of that coming back to the high strength, low alloy stuff. Like Andy said, you don't have to melt it. You don't necessarily get it to a critical cracking type of area. And I know that comes back to one of the questions that we had again on, can you restate what your cage was made out of?
Yeah, the cage is made out of the Docol. It's called Docol. It's DOCOL. The tubing designation is R8. Docol has been around for a long time in the automotive industry. It's one of the reasons that crash test ratings are now as high as they are because it is a high strength steel, and it was designed for the automotive manufacturing market where you're doing all types of welding. You can resistance spot weld it, you can MIG weld it, you can TIG weld it. So it's a lot more flexible of a base metal. It was originally designed in sheets, so it can be stamped into parts and, subframes, core supports, inner door supports, A post, B post supports. So that's kind of where that strength profile comes from. Well, the company decided to precision roll it into tubing. It's actually precision rolled and seam welded. Now, normally seam welded tubing you wouldn't want to use in a roll cage, but this is the only seam welded tubing that's actually approved by the NHRA for their top fuel classes. So all these classes that normally use chromoly are now some of those are switching into the Docol stuff, which is now acceptable. The welds on Docol are not compromised in the heat effect zone like they would be on, say, chromoly or other high strength steels. Another advantage to the Docol is it's not dependent on where you bend the tubing. So if you bend the tubing with the seam up or bottom or on the side, it's still going to not compromise that joint. So that is an advantage when making your roll cages as well. Another reason I really love Docol is it already comes clean. I just wipe it off. Whereas when I'm TIG welding chromoly, I actually take emery cloth and I clean all the weld joints up to get the mill scale off before welding it. So that actually eliminates a step for me too.
Excellent. We appreciate everybody joining tonight. We appreciate everybody out on the SEMA show floor. I wish I could be out there today, but instead I am here in the snow land of Michigan this morning. So we appreciate everybody's time again. Thanks for joining, and we'll see you on the next one.
Andy, Travis, James, Josh out here on the SEMA floor. Thanks, guys.
Thank you.
Thank you.